Thank you all. Thank you for having me here. I'm a developer advocate at JetBrains. I started as a developer in a Kotlin compiler, but now I do not write the code because I mostly do talks and write text and write the book. And basically the reason was like when we started the project, everyone came and asked who wants to do the talk about Kotlin, and it was always me who answered, yes, I want. So at some point they asked me, why won't you do that as a main job? So now let's start it with Kotlin. And we will talk about Kotlin in general, what it gives us as developers, how it can improve our lives. And I want to divide my talk into 3 parts, into an attempt to explain why actually this announcement happened, why Kotlin gives us a value and which value it provides us. So I want to emphasize that Kotlin is a modern and pragmatic language. And it happened to be Android friendly. So let's start. So now it's officially supported on Android. We're very happy to be here, to be at that stage. And I can say that we were surprised at JetBrains, so we didn't expect it. And all the times people ask me like, when Google will announce the support? It's like, ask Google, not me. I have no idea. So we knew a little bit in advance, like 3 weeks in advance, and we were really, really happy and surprised. But now we have a difficult task because Kotlin is actually, it is not designed specially for Android. We didn't have this goal like to write the language for Android. Our goal was to write a language which will have the goal of like be a better Java. So several years ago, when we started the project, main language for majority of the projects inside JetBrains was Java. And at that time, it was only Java 6, Java 7 wasn't yet, and Java 8 was far ago. And there was a wish to fix something in the language, to add some new stuff, to change some stuff, etc. And there was no the language that satisfied the needs. So at JetBrains, they decided to create their own language. And it happened so that it fits nicely for Android. And now we have a really difficult task to emphasize that it's not only about Android. So we focus on Java. And also we have compiler to JavaScript. And one more thing, we now have the compilation to native bytecode, to LLVM. It's now the work in progress, but probably in the future, no promises yet, for sure, but our goal is to be able to write code that can be compiled to both Android and iOS. I don't mean for sure the UI code, but probably some common logic, common business logic. But it's the work in progress now, so that's something we work on now. But we have some prototypes, you can check them, but it's not ready yet. Yeah, so let's discuss these modern and pragmatic words, and let's start with pragmatic. I would emphasize on 2 things. At first, when we are talking about pragmatic language, what we understand by that. We are the company, like the JetBrains company, it's creator of IDEs for developers. And in JetBrains, we think that nowadays every language goes with its tooling. So tooling is as important as the language itself. You can expect this attitude from JetBrains, I suppose. So the goal was to create a language with a good tooling support. And another thing that is important is interoperability with Java. So yeah, it's from JetBrains, it has good tooling, and so it provides you all the things that you used to have in Java. So if you have like your favorite intentions, inspections, refactorings, you can try them, and they will work for Kotlin for now, at the moment. Another important thing that actually probably explains why we have now official support for Android. Why Kotlin, not some other JVM language, is that it can be easily interoperated with Java. So you can mix them in one project. As every JVM language, Kotlin compiled to Java bytecode, and then you can then you can run it on Android as well. So again, it's not special for Android. It's just compiled to Java bytecode. But the thing is that it's not only possible to call Java code from Kotlin. This works for every JVM language. So if the language is compiled to Java bytecode, that works. You can call Java code from it. But for Kotlin, it works the other way as well. So you can add Kotlin code to your big legacy Java application or just existing Android application written in Java. You can add Kotlin there, and you can add tiny parts written in Kotlin to the existing application, and you can invoke new code from your code base. That's crucial. That's why it's different from other languages, and that's why now we have so big adoption. So you really can add a little bit of Kotlin into your existing applications. So that's an important thing, and we will return to it during the talk while we will look at some or other Kotlin features. So it happened to be Android friendly. At first, I would say without it would never happen. So Android Studio is based on IntelliJ. So Google have some experience of interoperability, of communicating with JetBrains folks. We have some channels established, some communications of what should be done and how it works. So without it, we would never have Kotlin. And having Android Studio based on IntelliJ, Kotlin plugin is written for IntelliJ, but it just works for Android Studio as well. So, and now you will have the Kotlin shipped with Android Studio also. Another thing why Kotlin works well for Android is that when you add Kotlin to your application, it doesn't require you to add a lot of methods, a lot of classes. So it can be compared to just adding another library to your application. Why? In Kotlin, we do not have such thing as Kotlin SDK. We do not have our standard library. We use Java standard library by default. We just provide a bunch of extensions to that. So do not having the big library to add, we have small runtime jar that you are actually adding to your application. That's why it works. And also, this thing as not having this design decision of not having our own library brings us easy Java interoperability. So it's not only choice, because other JVM languages, for instance, Scala, they have their nice, new, shiny library that is, in some senses, that is much better than Java library, but it's hard to interoperate, to mix Scala and Java in this sense. So this was like our design choices when we did Kotlin, how we want to achieve this good interoperability with Java. So now let's look at some code, real code, and discuss why Kotlin is a modern language. And I want to say here that, so we will have, the rest of my talk will consist of 3 parts that modern, for me, means concise, safe, and expressive. And I want to emphasize here that this modern language, this works not only with Kotlin. So the same issues work, for example, with Swift. And if you're an OS developer, you will understand that what I'm going to talk about very easily, because yes, it has the similar concepts. They have a lot in common. So it's not just about we have written something, but it's how, in general, we see what a modern language should look like. And you will really, you will find a lot in common between Swift and Kotlin. So when they released Swift, we were like, yeah, it looks very similar. Yeah, it looks very similar. And it's not who have stolen which features. No, it's more about how we, in general, now consider a modern language, what it should be. Probably it will, so not probably, but I'm sure it will change in 10 years. but we'll have more expertise, we'll have more experience. But that's what we have for now. So let's continue. About conciseness. This is a very typical slide that like every JVM language shows as an introduction to it, and Kotlin is no exception here. So this is a Java code. This is a regular Java class. And the thing is that now we can do better. So now we know how to express the same concept in a more concise way. And here I want to also illustrate the tool that helps a lot when you start to adopt Kotlin into existing Java project. We have automatic Java to Kotlin converter. So if you start using Kotlin, you're probably not already familiar with it, you can just write the code in Java, convert it, and see how the same code looks in Kotlin. And the converter produces the following result for the Java code. It's a little bit shorter, a little bit more concise. And again, it works not only with Kotlin. So in other modern languages, JVM languages or Swift, they have the similar concept. So now we know that we want to express it in an easy fashion. And also in Kotlin, you can add data modifier that will generate a bunch of useful methods for the class, like equals, hashcode, string, and some others. But at this point, you can ask me, but what about interoperability? So I've told you, Java can be easily mixed with Kotlin. So OK, I write this class in Java. So how would I mix this? Sorry, I'm writing this class in Kotlin. How would I mix this with Java code? And my answer is easily. Because OK, so this situation, when I write the code in Java and I call it from Java, it looks like calling a getter. I write this code in Kotlin and I call it in Kotlin. It looks like calling a property. But I can write this code in Kotlin and call it in Java as a regular getter. So under the hood, this class is generated to the similar bytecode that we have for Java. So it just produces the same constructor and getters. So from Java, we will call this getter, the same as Java. But it works in the other direction as well. So basically, if you have your Java class, and this Java class declares getters, you can call them from Kotlin as properties. And it works with all existing Java libraries. So your code in Kotlin that uses existing Java libraries looks like more Kotlin code than Java code. Another example of the converter in action. Example which shows that converter not every time produces the best result. So sometimes you use the converter. It gives you the code, which is very similar to Java code. But you have to improve it somehow. You can improve it often. So let's look at an example. So we have like update weather function that has to initialize just two variables, description and color. We have a name of two colors. And we have some code that initializes it depending on the weather. I'm not sure it goes for Australia. I don't know what's called for you. I'm from Russia, so for me it was like minus 10 probably. It's cold. I'm not sure I have this weather here. So again, I can use the converter. And I can also copy the Java code and paste it in my Kotlin file. It will suggest to convert it. And you see that converted code looks very similar to Java version. Yes, they are very much the same. So yes, we have different keywords. We have fun, we have val, we have types under the variable declaration. But otherwise, the code is very familiar. So if your colleague starts to write Kotlin, probably you will then you will understand what's going on because it's not that different. But we can do better. First thing we can notice is we have to repeat this variable name. So let's instead just declare just initialize two variables at once. And you see that in Kotlin, if returns a value. So if returns a result that you can assign to two variables. But that's not all. We see that we have these types that are actually, in this case, they are clear from the context. So Kotlin is a statically typed language. It's like Java. Every expression has a type. Every function declares its return type, it's the type of the parameters. However, in Kotlin, the compiler can infer these types for you if they're clear from the context. So in this case, we can just emit the types, and the compiler understands that, yes, the first one is string, the second one is color. One more improvement. In Kotlin, we have the when expression that is very similar to switch expression in Java, but it's much more powerful. And it happens that we can often use it instead of if, else, if, else, if, else. So in this case, we replace if with when, and we have this code. One last improvement. Instead of creating a pair, we can use the tow function in Kotlin. So this was our replacement. And that shows that this example, this small example, demonstrates basically how your code changes when you switch from Java to Kotlin. So it's the often case that your file decreases in size, like probably 2 times. It's not a radical change, but the code looks much nicer and much easier to read. And it also demonstrates that converter not always produces the best result, but it gives some time to get accustomed to new language, to start writing the code in more Kotlinish style. But at first, when you switch, you can just start using the converter and produce very similar to Java result, and then learn slowly. Slowly move to new language, slowly add it to your system, and slowly learn how it works. That's possible. Another aspect of being a modern language, again, it's not only about Kotlin, it's about our world in general, how we can do things. It's about safety. And this one I want to illustrate by this common thing, so-called billion-dollar mistake. So Svetlana Isakova, who once invented this null reference, told that it's hard to estimate how much money we spent as a whole on fixing these null pointer exceptions. So the problem is that you have null pointer exception, some problem occurred, and you have no information where it comes from. And we want to fix it. And the modern approach, again, it's not only about Kotlin, it's in general, works in general for many languages, is to make null pointer exception a compile time error, not a runtime exception. So instead of having these exceptions at runtime, we want to prevent them while writing this code. Again, it's not only about Kotlin. So Java 8 have another solution for this. Which one? What is the solution of Java 8? It's, again, it's optional, just optional. And in Kotlin, by the way, it's very similar to Swift. They have the similar concept in Swift. We have so-called nullable types. So in Kotlin, we distinguish a regular type that can contain, that cannot contain null reference with a nullable type that can. So if you try to store null in a regular type, the Kotlin compiler complains and says, no, you cannot do that. But if you want to store null reference in a nullable type, that works. And when you try to dereference the reference of non-nullable type, it works fine. If you try to do the same with nullable types, it doesn't work. And Kotlin provides several ways to fix this, to work with nullable types. So how to dereference them. You can check explicitly, but you can do better. You can, even the IntelliJ suggests how to fix this. You can replace this with safe call expression. Probably in Sweden they have the same syntax. Who is a developer there? Yes, so you know it. So it's something that you already know. Great. And this is, when we designed Kotlin, at first it was, I can say, stolen from Groovy, but they once told me to say borrowed, not stolen. But we never know. It's like the languages develop, and they all look at what is happening in other languages, just to keep in pace. So yes, there are several operators to work with it, and if you want to return null as a result, you can change this if with safe expression, so it returns null if the variable was null. You can provide the default value. The Kotlin compiler is quite smart, so if you check for being null and return a fail, it will understand that, yes, here the reference is not null and you can dereference it. And there is the part that is different from Swift, I know, because in Swift they have one exclamation mark, and in Kotlin we have two. That means please not use it. So the thing is that if you want to throw null pointer exception explicitly, you can do that by putting two exclamation marks. Important thing, how these nullable types are implemented under the hood. And actually, they are just annotations. That's probably one more thing that is different from Swift. They are just annotation. They are not wrappers, so there is no performance overhead. So these nullable types exist only when we compile code and on function signatures, but not at runtime. So at runtime, they are just regular Java objects. You can ask now, what about Java interoperability? So how do these nullable types work when you mix Kotlin and Java in one project? And the answer will be, try to annotate your code. So basically, when you use Kotlin or Java type, regular Java type from Kotlin, it behaves like regular Java type. That means that when you call Java code from Kotlin, you still can have null pointer exceptions. There was a long story why we did this, because at first we tried another solution. They didn't work. They work not very nice. So at last we have chosen this approach to provide you easy interoperability. So we decided not to go with default nullable types to be able to easily use Java code from Kotlin. So yes, you will still have null pointer exceptions if you just use Java code. However, if you annotate your Java code, these annotated types will be converted directly to nullable or non-null types in Kotlin. And actually, I'm talking about something new now. So these annotations will be introduced in the next Kotlin release. So so it's not there yet, but it will be there soon. And so this one works from the beginning. So if you annotate your Java types as nullable and with nullable or not null annotations, they will be converted to nullable and not null types in Kotlin. And now you can also say that, OK, I want non-null by default. And we now supported GSR 305, if everyone knows, if someone knows. And you can say, OK, my code, so I want to provide only nullable annotations and everything else is now null by default. So basically, the solution is the following. You can interoperate with Java if you do not think it works like regular Java, but if you want to improve, you can just add some annotations to Java, to your existing Java code base, and it will feel much better from Kotlin point of view. So you can work with this, or you can a little bit try to improve your existing code base. Both options work. Another thing, sometimes there is this misconception. Nullable types, it's not the same as optional. Optional is a wrapper that stores whether there is a variable or no value beneath. And nullable types are just annotations. So sometimes this misconception happens. OK, let's continue then. And discuss the last point of this being a modern language, expressiveness. It's a hard term. So I would say this basically is about ability to extract the repetitive code into libraries, to create expressive API, or to create API that looks and feels like something specific to your task. And I want to cover some Kotlin features, again, 3 features, to demonstrate how Kotlin can be an expressive language. First, I will talk about extensions, extension functions. It is a feature that is already present in some other languages like C#. So again, we haven't invented it. We just borrowed it. So let's look what is it. So in Kotlin, you can declare a function. You can extend a class with a function that lives not inside the class, but somewhere else. Like in this example, we use Java string in Kotlin. I've told you that we do not have our library. We use just Java regular strings, but we want to improve them. So I would say that, yeah, Java string lacks some useful methods, and a lot of libraries just try to provide their own bunch of extensions to them, util functions that work with strings and try to improve them. And Kotlin is no exception here, but you can declare such functions in Kotlin as extensions. So here string is a receiver parameter, and you can refer to it using this inside the function body. And as usual for this, it can be omitted. So you can just declare this function like this. Why would we need it? Extension functions can be called from Kotlin as members, as regular members. And also, they can be found in completion. So how do we write Kotlin? Like, what can be called on this item, on this some type that comes from the library? And you just look through the completion list. And here, all these extensions are visible in completion, so they can be easily found from there. In Kotlin, you have to import them explicitly. So if you want to use extensions somewhere, you have to import it. And you can ask me, OK, but what about Java? So how would you call these extensions from Java? I've told you that, yeah, you can easily call every new Kotlin code from Java. What do you think? Do you have any ideas who knows Kotlin? So actually, it works like this. So how would you declare such function in Java, in regular Java? So you have last char functions. Where would you put it?
Static.
Yes. Yes, static utilities. Yes, that's exactly how it's implemented under the hood. So actually, it is compiled as static utility that takes string as a first parameter. That's exactly the case. That's exactly how would you do that in Java. So calling extensions from Java looks like regular Java. Nothing changes. And you can import it statically in Java, and it looks like regular Java. Another difficult question for you to wake up at the beginning of the conference. Is it possible to call a private method of string from this extension function? What do you think? No, of course not, because it's just a regular static method under the hood. So you see, you start to know Kotlin. You can declare nice extension functions for Android, like this one. Why is possible? Because you just, here you see that we pass this as an activity, but we can declare extension function on activity, and pass is on this reference, and so it looks much more nicer in end code. The same works with starting a new activity. You again declare a function on an activity that does exactly this code, so nothing more complicated. And you can improve the readability of your Android applications in this manner. OK, there is this to function. You remember, I had it in my first example when I told you how to convert the weather example. So what is to? To is another extension function declared in the library. Actually, it's infix function, so you can either call it in a regular syntax or in an infix syntax. And there is a nice way to create maps. And this pattern actually is quite often in Kotlin. Something that looks like a built-in language construct, in fact, is a library function. So at the first glance, to looks like something special. But actually, it's just a regular function defined in the library. One more topic to cover. I expect that you are all familiar with this, so I won't tell you something new, so we won't go deep into what the Lambda is. But actually, it's again about what do we have in our modern languages. So now it happens that the functional, so Lambdas goes from the functional programming, from the functional approach, and now it happens that in modern languages, we we can do better when we have the support of functional programming in some sense, in one way or the other. So in Kotlin, you can use Lambdas. You can use Lambdas instead of anonymous class in Java, like whenever you want to provide a listener that has only one method, you can provide a Lambda instead. That should be quite familiar. Also, Kotlin provides the way to work with collections, with Java collections under the hood in a functional style. So you can say, like, you can filter collection, you can map collection. It's not, again, it's not a Kotlin invention. It's known in many different languages. It now supported, like in Java 8. It first appeared in Scala, and then it turned out to be quite useful for real development, not only in academic. And here, it refers to a parameter of the lambda, and like of the type of employee. And what I wanted to emphasize here that we provide all these functions that allow you to work with collections in a functional style as extensions functions defined in the library. So you may see the whole picture. So we do not provide our own library, our collections libraries. We use Java collection libraries. We have extensions. So our library is just a bunch of extensions method on this collection library that improves your experience with them. And it not only extensions, so Kotlin standard libraries consist of extensions on collections, but if you're talking about Android, then Kotlin provides Anchor library as a collection of extensions specifically for Android. And if you use some framework, Java framework or Java library from Kotlin, again, you can just use it as is, or you can extend it with some bunch of extensions to just improve your experience. Another important issue, again, it's about why it happened to be so useful in Android. Lambdas can be inlined, so there is no performance overhead. You know, for instance, if you use RxJava from Android, for every Lambda, if you target, obviously you do not target Java 8 yet, so if you target Java 6, for every Lambda, anonymous class is generated, so you have a bunch of extra classes. And with Kotlin, there is no issue, because Lambdas can be inlined, and we do not have to create these anonymous classes. So we just inline the function body and with Lambda body, so there is no performance overhead. OK, now the last feature I want to cover, the one that wasn't so explicitly stolen from someone else, something new. And it actually somehow unites these two ideas. Extension functions and Lambdas. So if you think about it, extension function can be considered as function with the receiver. So you saw this. There's function body and string as a receiver. And so there are regular functions and functions with the receiver. And so the same idea applies to Lambdas. We have regular Lambdas and Lambdas with the receiver. Everything is clear, yeah? You just unite two concepts. OK, let's discuss. Let's look at it. And let's start with the example. There is a very simple code. So just you create a string builder, you append something, some text, then you append it in a loop, and then you return the result. In slides, I use SB as a variable name. But I suppose that in real life, you will call it string builder. And you will have to repeat the string builder into several lines. And if you work with another variable, you will have to repeat its name. So in Kotlin, you can do better. And you can use with string builder. And instead of repeating this name, you use it once. And then you call all its method in this block just without a specific annotation. So that's clear. With is present in different languages like Python as a language construct. And the most interesting thing in this slide is its name. It's called the with function. So you see the same pattern follows. Something that looks like built-in construct in the language actually is a function defined in the standard library. So somehow we are able to define this as a function. Let's investigate. So okay, we did a function. Actually, this block of code is lambda, which is the second argument of the with function. In Kotlin, we have the following convention. We can say that if your lambda is the last argument, you can move it out of the parentheses. So you can put the parentheses first, and then the lambda. Another way to express the same code would be write it explicitly. First argument, second argument. However, it's not that readable. Now it doesn't look like a built-in language construct. So this syntactic convention works great for us. And this is an implicit receiver in this lambda. So actually, lambda with receiver is lambda that has this as an extra argument. And as usual for this reference, as we know, we can omit it. And now it looks like something built-in, something special, something that has special support. If you're interested, you can investigate how it's declared. So the declaration is quite simple. It's just one line. So we basically just call the block on the receiver. And Kotlin standard library declares several such one-line functions that are very useful when you write code. So if you start working with Android, with Kotlin, it's very easy to start using functions like with, apply, and also. And in fact, they are declared in the standard library. And what's more, you can declare, so yeah, there's lambda with receiver, this implicit this. You can declare, you can use the same pattern, not only for these lambdas, for these one-line functions, but also I want to demonstrate this example. We support something like builder's pattern. There is an example with HTML, basically because everyone knows HTML and everyone understands what's going on here. But it can work for every XML structure, for every XMLs that you have in your project. So what's here? We have these HTML builders that looks like HTML with different with curly braces. And actually, these all are just functions. You see that we're mixing here the regular code and HTML syntax. And under the hood, these all are lambdas with receiver. You can investigate it later how it can be declared and work. But the idea is that you can use the same pattern for different applications, for different XML structures in your code. And it all works with lambdas with receiver. And also now, probably you know that Gradle supports, they haven't released yet, but now they want to be able to write build scripts in Kotlin. And there the same strategy works. So they use these lambdas with receivers a lot. It's a very powerful feature that allows you to write DSLs. And Gradle is just one of the examples, one of the real examples. Probably won't write HTML, but I suppose more like build scripts. Yeah. And you can also use this type of functionality, this feature, in your own code bases. If you have some repetitive pattern, something that is specific for your application, and with just a small piece of code that changes from time to time. So instead of copying it from method to method, you can actually extract it into a function. With using lambdas, with the support of inline, you can extract it, and it looks much more concise and much more readable. And now, instead of copying this full code, you just copy this method. And you just call it. And for instance, if you have to catch your specific exceptions in this pattern, you can easily do that. You have to change it one time in the library. That's how the code reuse works, actually. So Kotlin gives you more power for this code reuse. And again, lambdas can be inlined. And when you declare such function, you can declare it as inline function. And the generated bytecode will be similar to what you would write by hand. So you don't have to create anonymous class for each lambda. You can extract it and inline it, and it works like you would write it by hand, but actually it looks more concise and readable. Another application of the same builder pattern is we have domain-specific language for dynamic layouts. Actually, we have Anchor library for extensions for Android, and we have part Anchor DSL. It's not that clear what future expects it now when Google have the support for Kotlin, because probably they will have some official recommendations what to use. But still, it demonstrates the core idea, what can be done with Kotlin for Android. And what can be done is that you can express some similar layouts using just regular Kotlin code. And if you compare, it's very clear what's going on here. So alert, you see there is title, message, and 2 buttons. And actually, alert is a function that takes 3 arguments. The last one is lambda with receiver, again. And positive button and negative button can be called on explicit this in this lambda. So the same button again. It's quite powerful. You can create very readable constructs with it. The same works for more specific layouts, custom layouts. You can express it like this. So again, it's a powerful feature, but we'll see what awaits it with the Google support. So I think I'm already there. At last, some references. So we have the Kotlin site. As I already mentioned, Gradle supports Kotlin, so you will soon be able to write build scripts in Kotlin. And some features that supports DSL help us here, something like Lambdas with receiver, as we saw. If you want to learn Kotlin, one of the ways would be to try Kotlin commands. We have them available in the browser, as well as a standalone project for IntelliJ. So there is just 42 tasks to complete, small tasks, and actually they have answers and keys, so you can check it if you want. You can tweet about them afterwards. And also we have a book written about Kotlin. It's already there. It doesn't cover our latest feature of coroutines, but probably it would cover it in the future. So thank you all, and have a nice Kotlin.